The question of how the pyramids of Egypt were built has persisted for more than 2,000 years, not because the ancient Egyptians left no evidence, but because the scale and precision of their work continues to challenge modern assumptions about ancient capabilities. A serious investigation begins not with speculation, but with chronology, archaeology, and physical evidence. The construction of the Great Pyramid of Giza took place during the reign of Pharaoh Khufu, around 2580–2560 BCE, in the period known as the Fourth Dynasty of the Old Kingdom. Egypt at this time was not a primitive society. It was a centralized state with a powerful administration, a taxation system based on agricultural surplus, skilled labor divisions, and a long tradition of stone construction that had already evolved for centuries before the first pyramid was attempted. Before pyramids, Egyptian elites were buried in mastabas, rectangular, flat-roof structures made of mud brick or stone. Over generations, these mastabas grew larger and more complex. The transition from mastaba to pyramid did not happen suddenly. It began with experimentation. The step pyramid of Djoser at Saqqara, built around 2630 BCE under the supervision of Imhotep, represents the first large-scale attempt at stacking stone vertically. This project established quarrying methods, stone transport techniques, workforce organization, and the basic principle of monumental stone construction. By the time Khufu came to power, Egypt already possessed decades of experience building in limestone and granite. The Great Pyramid was not an isolated miracle. It was the result of accumulated knowledge, refinement, and administrative planning. The first step in construction was site selection. The Giza Plateau was chosen because of its solid limestone bedrock, which could support immense weight without settling. Geological surveys confirm that the pyramid's foundation rests directly on leveled bedrock. Workers cut into the rock to create a flat base with remarkable accuracy. Modern measurements show the foundation is leveled to within a few centimeters across its entire area, achieved without modern surveying tools but using water trenches, plumb lines, and siting techniques. Once the site was prepared, quarrying began. The majority of the pyramid's core blocks were cut from limestone quarries located directly on the Giza Plateau. Tool marks preserved on unfinished stones show the use of copper chisels, dolerite pounding stones, wooden mallets, and wedges. These tools were sufficient because the limestone is relatively soft when freshly quarried. Experimental archaeology has repeatedly demonstrated that teams using replica tools can cut limestone blocks at rates consistent with archaeological timelines. The casing stones, which once covered the pyramid and gave it a smooth white exterior, were made of high-quality Tura limestone quarried from the eastern bank of the Nile, over 10 kilometers away. Granite used in the king's chamber was quarried at Aswan, more than 800 kilometers south. Quarry inscriptions at Aswan and transport marks on blocks confirm this origin. Transportation relied on the Nile. During the annual inundation, canals and harbors connected quarry sites to construction zones. Archaeological discoveries at Giza, including a large ancient harbor and papyri found at Wadi al-Jarf, provide direct written evidence of logistics. The Wadi al-Jarf papyri, dated to Khufu's reign, record the daily activities of a work crew transporting limestone blocks by boat from Tura to Giza. These documents describe loading stones, sailing schedules, and delivery points, confirming a centralized and organized supply system. Once blocks arrived at the plateau, they had to be moved across land. Wall reliefs and experimental tests show that wooden sledges were used, with teams pulling ropes while water was poured in front of the sledge to reduce friction. A tomb painting from the Middle Kingdom depicts this exact method, and modern physics experiments confirm that wetting sand significantly lowers drag. Raising the stones to increasing heights remains the most debated aspect, but it is not without evidence-based explanations. The prevailing models involve ramp systems, not a single massive ramp, but a combination of straight, zigzagging, and possibly internal ramps. Archaeological remains of ramps have been found at other pyramid sites, such as the Pyramid of Senusret II at Lahun and at Hatnub, where an inclined ramp system with staircases and post holes for rope anchors was discovered. The internal ramp hypothesis, proposed by engineer Jean-Pierre Houdin, suggests that stones were hauled upward through a ramp embedded within the pyramid's structure. While this model is still debated, it is grounded in architectural logic and supported by microgravimetric scans that reveal density anomalies inside the Great Pyramid, consistent with internal voids or corridors. As construction progressed, precision became increasingly important. Surveying was conducted using sighting rods aligned with circumpolar stars. The pyramid's near-perfect cardinal alignment, accurate to a fraction of a degree, indicates astronomical observation rather than magnetic orientation. This technique was within the known capabilities of Old Kingdom astronomer priests. Workforce organization is one of the most misunderstood aspects of pyramid construction. Archaeological evidence shows the pyramids were not built by slaves. Excavations of worker villages at Giza reveal well-fed laborers who lived in organized housing, received medical care, and were buried with honor. Animal bones found at the site indicate diets rich in meat, bread, and beer, consistent with state-supported labor. Labor was likely seasonal. During the Nile flood, when agricultural work was impossible, tens of thousands of workers were mobilized for state projects. Skilled craftsmen worked year-round, while rotating crews of laborers provided manpower during inundation months. This system allowed Egypt to sustain massive construction without collapsing its economy. Inside the pyramid, structural engineering was carefully planned. The king's chamber ceiling uses massive granite beams arranged in relieving chambers to distribute weight and prevent collapse. This design demonstrates empirical understanding of load management. The Grand Gallery served as an internal transport corridor and counterweight system, aiding the movement of heavy stones upward. What researchers know with certainty is based on physical remains, tool marks, inscriptions, logistics papyri, experimental archaeology, and structural analysis. The materials used, the workforce organization, the transport routes, and the construction timeline are supported by multiple independent lines of evidence. What remains uncertain concerns specific ramp configurations, exact daily labor numbers, and some internal construction sequences. No ancient blueprint survives. Knowledge was transmitted orally and practically rather than through detailed architectural texts. Modern researchers continue to study the pyramids using non-invasive technologies such as muon tomography, ground-penetrating radar, and 3D modeling. These methods have revealed previously unknown voids, but have not produced evidence of advanced or lost technology beyond known ancient methods. The pyramids were not built with magic, extraterrestrial assistance, or forgotten super technology. They were built through organization, experimentation, skilled labor, and the sustained application of simple machines over decades. The real mystery of the pyramids is not how they defy physics, but how effectively an ancient society mobilized human labor, natural resources, and empirical knowledge to achieve a result that still stands today. The question of labor numbers has been studied carefully by modern researchers using realistic construction rates rather than exaggerated estimates. The Great Pyramid contains approximately 2.3 million stone blocks, but they were not all placed at the same pace or by unskilled hands. Many blocks were small enough to be moved by teams of a few men, while larger stones required coordinated crews using sledges, ropes, and levers. Experimental archaeology shows that a well-organized team could quarry, transport, and position dozens of blocks per day when working close to the construction site. Calculations based on quarry output, transport capacity, and placement rates suggest a total workforce of around 20,000 to 30,000 people at peak activity, not the hundreds of thousands described by ancient Greek writers centuries later. This workforce included stonecutters, haulers, surveyors, toolmakers, cooks, physicians, administrators, and overseers. The pyramid was not built by brute force alone, but by a carefully managed labor economy. Tool evidence further supports this interpretation. Copper chisels found at Giza show heavy wear and frequent resharpening, indicating continuous use. Dolerite pounding stones discovered in quarries demonstrate how harder stone was shaped without iron tools. Wooden levers, though rarely preserved, are depicted in reliefs and implied by the physics of stone movement. Simple machines multiplied human effort rather than replacing it. The internal layout of the Great Pyramid also reflects adaptive problem-solving rather than rigid pre-planning. Changes in corridor angles and chamber placement indicate that builders adjusted their approach during construction. This flexibility is consistent with large-scale projects managed without written blueprints, relying instead on experienced overseers and on-site decision-making. Modern non-invasive investigations have refined, rather than overturned, this picture. Muon tomography has revealed previously unknown voids above the Grand Gallery, but their presence aligns with known construction strategies such as stress relief and internal transport space. Ground-penetrating radar and microgravity surveys show no evidence of hidden machinery, metal frameworks, or advanced technologies beyond stone, wood, and rope. Radiocarbon dating of organic materials found in mortar, combined with inscriptions left by work crews inside the pyramid, firmly anchors construction to Khufu's reign. Crew names such as Friends of Khufu and Drunkards of Menkora humanize the builders and confirm state-organized labor rather than coerced slavery. What researchers know, therefore, is substantial. The pyramids were built over decades using limestone and granite quarried with stone and copper tools, transported by river and sledge, lifted by ramp systems, aligned using astronomical observation, and assembled by a paid, housed, and provisioned workforce. Every major stage is supported by physical evidence and repeatable experiments. What researchers do not know lies in the details rather than the fundamentals. The exact shape of every ramp, the precise scheduling of each crew, and the full internal construction sequence remain subjects of study. These gaps exist not because the methods were extraordinary, but because the ancient builders did not leave behind technical manuals. Their knowledge was practical, transmitted through training and experience rather than written instruction. The pyramids endure not because they were built with lost technology, but because they were built with patience, organization, and an intimate understanding of materials and forces. They are monuments to human capability within known physical limits. Understanding how the pyramids were really built does not make them less impressive. It makes them more so. They were achieved without steel, engines, or electricity, relying instead on coordination, discipline, and generations of accumulated knowledge. The investigation into pyramid construction continues, not to chase mystery for its own sake, but to better understand how ancient societies solved complex problems with limited tools. Each discovery adds clarity rather than confusion. The pyramids were not miracles, they were achievements. If you want more evidence-based explorations into ancient mysteries, lost knowledge, and how the ancient world truly worked, subscribe to the channel and join us as we continue uncovering history, one unanswered question at a time.